this is lesson 93 in Saxon's Algebra 1 3rd edition book, and this is one of my favorite lessons. This is on products and quotients of rational expressions. And again, this is one of those things that goes right back to the heart of factoring and knowing how to factor. Remember, I told you a long time ago that factoring is one of the key concepts in algebra, and knowing your multiplication tables is a key concept in factoring. So math does build from year to year, and you're not going to forget what you've done one year, and you're going to need it the next year. All right, so products and quotients of rational equations. To do this, this looks really complicated here. You've got all this times all of this, and how in the world do I even begin? Well, good question. You begin with factoring each one. And remember, if there's a common factor, like in this and this, you have to factor those out. All right, so we're going to factor 4 different numbers. This is a perfect square, so x plus 5, x minus 5. Here we have a common factor of x that we'll take out, and when we take it out, we're left with x minus 7. Same thing here. If we take out the x that's common, we are left with x plus 3. And then down here, we're actually going to do old-fashioned factoring, which is x and the factors of 15 that would add or subtract to give us 2. We need a negative here, so we need one negative and one positive, and we need the one positive that's going to give us a negative here. So the factors of 15 that we're going to use are 5 and 3. The 5 is actually going to have to be negative because negative 5 and positive 3 would give us negative 2. Once we have factored everything out, then we're going to start another one of my favorite things, which is cross-canceling. We're going to cross-cancel everything we can. So this x and this x will cancel each other out. This x minus 5 and this x minus 5. This x plus 3 and this x plus 3. And then we're going to see what we're left with. We're actually left with x plus 5 on the top, x minus 7 on the bottom. And that is our answer to all of this. Isn't that fun? I love this. Okay, let's do some more. Okay, so we're going to factor all 4 of these. This would factor to x plus 3, x minus 2, positive 3 because we need a positive 1 here. On the bottom, the factors of 21 that would give us negative 4 are negative 7 and positive 3. So x minus 7, x plus 3. Over here we've got the factors of 7. There are only 2 factors, so those would need to be 1 and 7. But this is positive, and this is negative. So both of these need to be negative numbers to add to a negative 8. So x minus 7, x minus 1. And then down here, the factors of 2 are 1 and 2. We need to end up with a negative 1, so the 2 needs to be negative and the 1 needs to be positive. Then we're going to start cross-canceling here and here, here and here, here and here, as long as one's on top and one's on bottom. And then we are left with x minus 1 over x plus 1, which is the answer to all of this. All right, so that is products of rational expressions. Let's look at quotients. Okay, so you remember how we'd have to what's called rationalize the denominator, which means we're going to flip, we're going to divide. Here we're going to flip this and use the reciprocal so that we can get rid of all of this. So we do that. Then we have to do the same thing up on top, and then we're just going to multiply across. AD over BC. Now we could do this, we could say the same thing If this were written like this with the old-fashioned division sign instead of the fraction bar, which really means the same thing, we could see that, oh, we need to change this sign to multiplication, we need to invert the second fraction, and then we multiply, and we multiply across, we get the same answer. Isn't that easy? All right, now in this one, we've got kind of the same thing. All right, we're used to doing that, what we saw on the last page. But now we're moving into this more complicated, but procedure-wise, it's the same thing. This is the second fraction. So we're going to invert and then multiply. So when you have a division sign, you have to know that you've got to flip this one and then change this sign to multiplication. Then what you're going to have is a product of rational expressions instead of a quotient. Okay, so we do our factoring, take out the common factor here, you're left with x minus 2. Here the factors of negative 8 would be positive 4, negative 2, because we need to add and get a positive 2. Here, x squared plus 7x plus 12. The factors of 12 that would add to 7 are 4 and 3. And in this one, we're going to take out that x that's common and be left with x plus 5. Then we're going to look around. We've got an x here and here that can cancel out. X plus 4 here and here. X minus 2 here and here. And we are left with x plus 3 over x plus 5. And that is our final answer. Another example. Here's the original problem. It is a division. So we're going to change this sign to multiplication, and the second fraction we're just going to flip upside down. Now we're going to factor each one of these expressions. X minus 3, x plus 2 for this one. X plus 2x minus 5 for this expression. Over here we have x plus 4x minus 5 to give us a negative 1 there. And here we have x plus 4 and x plus 1. Then we cross cancel everywhere we can, here and here, here and here, here and here. And we are left with this x minus 3 and this x plus 1. And this is our final answer. All right, let's work our practice problems. Okay, so let's work our practice problems. First thing I'm going to notice is that this is a division sign, so I'm going to change it to multiplication. And I'm going to flip this second one upside down. And I'm just going to bring this one down like it is. And then I'm going to start factoring. Let's do that in a different color, shall we? Alright, so up on top, I'm going to have, in this one, x a plus and an x minus, because I have a negative here. Alright, the factors of 6 that would equal 1 when added together are 2 and 3, and I need that 3 to be negative, 2 to be positive. Down here I'm also going to be needing a positive and a negative, because I have a negative here. The factors of 16 that would give me 6 are 8 and 2. I need this 6 to be negative, so the 8 needs to be negative. Times, here I'm going to need a plus and a minus. X plus, x minus. The factors of 40 that would give me 3 would be 8 and 5. The 8 is going to need to be negative so that I can end up with a negative 3. And here I'm going to take out this common x, and I'm left with x minus 3. Alright, let's change colors again. I just love this changing colors. And let's start cross-canceling. I've got x minus 8, x minus 8, x minus 3, x minus 3, x plus 2, x plus 2. I am left with x plus 5 over x, and that is my final answer. Okay, in B, we have, this is a multiplication problem, so I'm going to take notice of that first. I always do that. So everything's going to stay like it is. I can go ahead and start factoring. Up on top, here, everything is positive, so it's going to be x plus x plus. Same thing on the bottom, x plus and x plus. And then times. Now here, I'm going to have a plus and a minus because I've got a negative here and here. So x plus and x minus. Same thing on the bottom. Alright, let's fill in the numbers then. The factors of 36 that would add to 12, obviously, are 6 and 6. The factors of 42 that would add to 13 are 6 and 7. The factors of 21 that would give me of negative 21 that would give me a positive 4 are 7 and 3, and that 7 is going to need to be the positive one, so I can have a positive 4. And then the factors of negative 24 that would give me a positive 2 are going to be 6 and 4, and I'm going to need the 6 to be positive and the 4 then to be negative. Alright, so let's go through and start doing our cross-canceling. Here and here, here and here, here and here, and I'm left with x minus 3 over x minus 4, and that is all there is to it. It's just so much fun, I think. I know, just a little bit nerdy there, but whatever. It's one of the things I enjoy in math. So, don't get tripped up. Make sure that you watch your signs. Make sure to invert and multiply if you have a division problem. And I will see you back next time for lesson 94. Good job.